Welcome to the class. Today topic is developments leading to the Bohr's model of an atom. Okay, what are the developments? What are the developments are leading to the development of the Bohr models? So there are certain models, there are certain issues which can lead to the development of the Bohr model. Okay, we know from the previous classes, we know Rutherford model has some drawbacks. So there is some after that there is some experiments, then some theories are leading to the development of the Bohr model. What are the experiments, what are the theories can leading to the development of the Bohr model? Okay, Bohr model is developed on the basis of drawbacks which as we know from the Rutherford nuclear model. Then from the drawbacks, okay, and from the note of the drawbacks and from the this type of experimental data and theoretical data which can lead to the development of the Bohr model. Okay, what are they? First one is dual character of the electromagnetic radiation. Dual character of the electromagnetic radiation which has wave-like and particle-like properties. Okay, electromagnetic radiation have both wave-like and particle-like properties. Okay, we know electromagnetic radiation. Okay, electromagnetic radiation has wave-like and particle-like properties. Okay, this is the one which can help the development of the Bohr model, and also experimental results regarding atomic spectra which can be explained only by assuming quantized electronic energy levels of an atom. Okay, experimental data results regarding atomic spectra. Okay, from the experiment we know atomic spectra. Okay, laterally we know atomic spectra. Experimental results regarding atomic spectra which can be explained only if the atom has quantized energy levels. If the atom has quantized energy levels, then only we can explain the atomic spectra. Atoms can give what is means of atomic spectra? Atoms can give the atomic spectra. Okay, which was explained by assuming atom has quantized energy levels. Then only we can explain this. So based on these two concepts, dual character of electromagnetic radiation and atomic spectra. Okay, atomic spectra and dual character of the electromagnetic radiation. These two topics were mainly leads to the development of the Bohr model. Okay, how Bohr model is developed is based on these two concepts. They were developed the Bohr model. Okay, experimental dual character of the electromagnetic radiation means electromagnetic radiation has wave-like and particle-like properties. Okay, next experimental results of atomic spectra. Okay, experimentally we know atomic spectra we can get it from the atoms, then which can be explained by assuming quantized energy levels of an atom. Okay, one by one we look into the this type of concepts. Let us look into the matter dual character of the electromagnetic radiation. Okay, how we can explain dual character of the electromagnetic radiation. Now let us focus wave-like properties of the electromagnetic radiation. Then we also look into the particle-like properties of the electromagnetic radiation. Okay, now we want to discuss in detailed concept of wave-like properties of electromagnetic radiation. How the electromagnetic radiation behaves as wave. Okay, how we want to know how electromagnetic radiation behaves as wave. We know what is the means of electromagnetic radiation. First of all, electromagnetic radiation, we know the light can emit, any light can emit electromagnetic radiation. These are the electromagnetic radiation. Sun is also emit the rays. These rays are also electromagnetic radiation. The sun emits the electromagnetic radiation. Our tubelights, our bulbs, all are emits the electromagnetic radiation. So these electromagnetic radiation have both properties, means wave-like properties and particle-like properties. Okay, let us look into this one by one. How electromagnetic radiation has wave-like properties first of all. Then we look into the another type of property, how electromagnetic radiation has particle-like properties. Okay, wave nature of electromagnetic radiation. Wave nature of electromagnetic radiation, how the electromagnetic radiations are generated. Okay, from the Maxwell point of view, oscillating charged particles generates oscillating electrical and magnetic fields which are perpendicular to the wave propagation are known as electromagnetic radiation. Electromagnetic radiation is created by oscillating charged particles. Oscillating charged particles can create the electromagnetic radiation. Those electromagnetic radiation can have oscillating electrical and magnetic fields which are perpendicular to the wave propagation. Okay, electromagnetic radiation is created by the oscillating charged particle which has electrical and magnetic components are perpendicular to the each other for the propagation of the wave. Okay, these two electrical and magnetic component, oscillating electrical and magnetic components are perpendicular to each other. Okay, one is in y direction, one is on z direction. This is in this way and this is perpendicular. These two, okay, this one and this one. Okay, these two has, okay, how can you say, these two, this wave and this wave, these two have 90 degrees. Okay, they are perpendicular to each other for the propagation of the wave in x direction. One of the component in y direction and another one of the component is in z direction. So one is electrical component or electric field, another one is magnetic field component. Okay, these two are propagating. So this wave is known as electromagnetic wave. This wave is known as electromagnetic wave. Electromagnetic wave can pass through the vacuum also. Okay, it does not require any medium. Electromagnetic radiation does not require any medium like sound waves and water waves. They require medium for their transmission, but electromagnetic radiation does not require any medium. This can pass through in vacuum also. Okay, they can pass through vacuum also, or electromagnetic radiation does not require any medium. Next point, there are different types of electromagnetic radiations. There are different types of electromagnetic radiations in the nature. Okay, these are closer together. Okay, we can study these together, is known as electromagnetic spectrum. Okay, electromagnetic spectrum means a different electromagnetic radiations are come together, they can form the electromagnetic spectrum. Okay, electromagnetic spectrum consists of different electromagnetic radiations. Electromagnetic spectrum consists of electromagnetic spectrum consists of electromagnetic spectrum consists of electromagnetic spectrum consists of different electromagnetic radiations. Electromagnetic radiations. Okay, there are different types of electromagnetic radiations. Okay, these are come together is known as electromagnetic spectrum. Okay, different types, we know electromagnetic spectrum has different types of electromagnetic radiations. These electromagnetic radiations are characterized by certain features, are known as electromagnetic radiations are differed by certain properties, are known as wavelength and wave number, frequency. Like these properties are variation to the one type of electromagnetic radiation and another type of electromagnetic radiations. So finally we can say electromagnetic radiations are one another differ by these type of properties are known as wavelengths, wave number and frequency. Like that properties that differ to one electromagnetic radiation to another electromagnetic radiation. Now look into the that concept. What is the wave number? What is the wavelength? What is the wavelength? What is the wave number? What is the frequency? Okay, let us know it. The wave characteristics means electromagnetic waves are characterized by certain properties. Electromagnetic waves, we know electromagnetic spectrum consists of different types of electromagnetic radiations. Electromagnetic spectrum consists of different types of electromagnetic radiations. These electromagnetic radiations one and each other differ by certain properties. The properties, let us know that properties. Frequency. Okay, what is the means of frequency? Wavelength and wave number. Okay, these are the properties and which can differ one electromagnetic wave with another electromagnetic wave. Okay, what is the meaning of frequency? Frequency is defined as number of waves that pass through a given point in 1 second. Number of waves. One wave means, we know this is known as one wave. Okay, this is known as one wave. Okay, one wave. Okay, known as one wave. Number of waves pass a given point in 1 second. This number of waves can pass a given point in 1 second. Okay, number of waves pass a given point in 1 second. In 1 second, number of waves can pass through a particular point. How many this type of waves can pass through that point in 1 second are known as frequency. Units, Hertz. Units, frequency units are Hertz. Next, wavelength is lambda. This symbol is known as lambda. Defined as the distance between two nearest crest or nearest trough. What is the meaning of it? Okay, distance between two nearest crests. These are the crests of the wave, the higher part. Okay, the distance between two subsequent crests or distance between two nearest troughs. Okay, this is means lambda. Okay, this distance between these two or distance between these two is known as wavelength. Okay, known as wavelength. Next, Wave number is indicated by nu bar. Okay, this is nu bar. There is a symbol like this, bar, nu bar. It is reciprocal of the wavelength. Okay, it is reciprocal of the wavelength. Reciprocal of the wavelength is known as wave number. Reciprocal of the wavelength is known as wave number. Okay, units is centimeter inverse, comma meter inverse. Okay, in CGS centimeters, in SI units meter inverse. Okay, these are the units they are used. Next, velocity is indicated by C. Velocity of wave is defined as distance covered by wave in 1 second. Distance covered by wave in 1 second is known as velocity. Okay, nu is equal to C by lambda. Okay, nu is equal to C by lambda. C is velocity of light. Is known as velocity of light. C is velocity of light. Velocity of light. Okay. C is velocity of light. Next, amplitude. Amplitude is indicated by A. Amplitude of wave is defined as height of crest or depth of the trough. Height is defined as amplitude is defined as the wave is defined as the highest crest or depth of the trough. Okay, we know the wave. The height of the crest or the depth of the trough is known as amplitude. Amplitude is one of the criteria of the wave characteristic. Okay, one type of electromagnetic radiation has certain type of amplitude, and another type of radiations have another certain type of amplitude. So amplitude is differ from one electromagnetic radiation to another electromagnetic radiation. Okay, velocity also depend on the electromagnetic radiation, what certain type of electromagnetic radiation, certain type of speed they have. Okay, this is known as electromagnetic spectrum. In electromagnetic spectrum, okay, with help of wavelength and frequency, you can differ one electromagnetic radiation with the another electromagnetic radiation. Okay, lambda, wavelength. Lambda means wavelength. Okay, wavelength. With respect to wavelength, okay, radio waves have greater wavelength. Okay, larger wavelength, 10 to the power of 8 meters. Okay, wavelength decreases. This becomes radio waves. Okay, and then microwaves, 10 to the power of minus 2 meters. IR waves, 10 to the power of minus 4 to 10 to the power of minus 6. And next, visible spectrum. Visible spectrum in between UV and IR radiation. Okay, visible spectrum or visible radiations contains in between UV and IR. Okay, this wavelength is in between these two, 10 to the power of minus 8 to 10 to the power of minus 6. Okay, it contains visible spectrum. Visible spectrum contains violet light, indigo, blue, green, yellow, orange, red. VIBGIRO. Okay, VIBGYOR. VIBGYOR. Okay, this is known as visible spectrum, is in between IR radiation and UV radiation. Next, after UV radiation, you go to the next X-rays. X-rays have very shorter wavelength. Okay, then compared to this one, wavelength is very lesser. Okay, compared to this one. And then gamma rays. Gamma rays have wavelength very much shorter than the 10 to the power of minus 10. It is a 10 to the power of minus 12 to 10 to the power of minus 18. So, wavelength is very much shorter. Okay. Next, with respect to frequency, frequency is higher for gamma rays than X-rays than UV radiation 10 to the power of 16. Whereas the frequency is gradually decreases from left to right. Left to right, frequency decreases. But the energy, which one is more energetic radiation? This one. Gamma rays are more energetic radiations than X-rays, than UV, than visible, than IR, than microwave, than longer radio waves. So, most energetic radiations are these. So, energy of radiation is proportional to E is equal to h mu. Okay, energy is proportional to the frequency. Energy is proportional to the frequency. Okay, which one is more energetic radiation? Gamma rays, then X-rays, UV, visible, IR, like that. Okay, next, which one have greater wavelength? Okay, greater wavelength, that one, longer radio waves. Radio waves have greater wavelength, but these have shorter wavelength. Shorter wavelength and greater frequency is indicate stronger radiations. Okay, energetic radiations, this one, then compared to this one and this one. This is known as electromagnetic spectrum. Okay, different types of electromagnetic radiations are come together, then we call it as electromagnetic spectrum. Electromagnetic spectrum is how it is built. There are different types of electromagnetic radiation. These are come together. The whole, this one is known as electromagnetic spectrum.